Hello everyone, my name is Satyam Umesh Bhagat. In this video, we are discuss about what is decision tree. We are a student of AISSMS Institute of Information Technology, Pune, and this PPT is presented by Satyam Bhagat, Pranav Kubal, and Sai Ghate. So let's see. Now let's see what is decision tree. A decision tree is a supervised machine learning algorithm. It helps us to make a decision by mapping out different choices and their possible outcome, just like a flowchart. It is used in machine learning for tasks like classification and prediction. The tree starts from a single main question called as a root node, which represents the entire data set. It has a tree-like structure that starts with the main question called as a root node, which represents the entire data set. This is the one of the example of a decision tree. It in this example show the flow chart of a decision tree. The above root node is called as a root node. In this root node, we have a two internal node, and inside the internal node, we have a two leaf node in the both internal nodes. Now let's see how decision tree works. The decision tree starts with the root node. The process begins with the main question derived from the database features and then asks yes no question. The data is split based on the simple yes no conditions. Branching each answer lead to the different branch, refining the decision path. Continue splitting. The tree keep dividing the data until the no further useful split remains. Reach leaf node. The final outcome or prediction is made at the leaf node. Let's consider the one example to decide whether to drink the coffee or not. If a morning asks tired, if the person or customer is tired, it get the drink coffee. So we assume that the customer or the person is tired. If person does not drink a coffee, then we remind that the customer is does not tired. In the afternoon, asks if tired, yes, drink the coffee. No, don't drink the coffee. Now let's see what is the real-time application of a decision tree. Decision tree are used in many real-world applications like loan approval in bank, used by the bank to decide the loan approval based on the conditions such as the credit score, income, and the history, and the customer civil scores. Medical diagnosis help to predict the disease like diabetes using the patient data like the BMI, blood pressure, etc. In education sector, predict if the student will pass or fail based on the attendance, study time, and grades, and the student previous year marks and the current semester examination score. Customer current prediction. Predict if the customer leave or stay using the behavior and purchase patterns. Fraud detection. Detect the transaction and flag possible fraud using the past data. Let's look at an example to predict whether the customer will buy a product or not. Example. In this example, we see whether the customer buy a product or not based on the customer salary. Let's first the root node. The decision tree might first ask if the income is greater than 15,000. If as it check the age. If else, then proceed the next question. We ask next question if the customer age is greater than 30. So this is our next internal node. In this internal node, we ask a simple question like if person age is greater than 30, then customer is definitely buy a product. As if the person age is not greater than 13, it definitely not buy a purchase. Second internal node is a previous purchase. We can also see the customer previous history, like a purchase or not. If person is above 30 and has made a previous purchase, like predict, this is our second internal node. In this internal node, we can see the customer history. If the customer buy a previous purchase and like any kind of product, then definitely customer buy a new product. If customer is not buy any kind of purchase, so it definitely no purchase. Now, here are some benefits of decision tree. Very easy to understand and interpret. No need for a data normalization or scaling. Handle both the numerical and categorical data. Help to identify the important features. Require little data preparation. No need for a scaling and encoding. Useful for the feature selection. Highlights important attribute during splitting. Can handle missing value. Work well with missing value. And suitable for the both the classification and regression problem. And as well as the some disadvantages also of a decision tree. So let's see what are the disadvantages of decision trees. Overfitting can create overly complex tree that does not generalize well. Unstable. Small change in a data can lead to complexity different trees. Bias toward features with more levels. Attribute with the many categories may dominate splits. Less accurate alone. Single tree are less accurate compared to the assembled model. Pruning needed. Require a pruning or setting depth limit to avoid overfitting. Continuous data split can be costly. Finding the optimal threshold increase the computation time. So let's consider what is the conclusion of decision tree. Decision tree are a powerful and easy to understand model that help make a data-driven decision. They are widely used across fields like finance, healthcare, and education for prediction, classification, and problem-solving tasks. They are a visual and interpretable structure, make them ideal for both the beginners and professional in data analytics fields. Let's consider the one of the example and code implementation with the help of decision tree. In this example, we predict the employee salary based on the employee work on which company, their education, and the certification of the employee. So first of all, to run the code, we require the Python version 3.8, and the code editor tool like Jupyter Notebook or the Anaconda. As according to the our laptop, we include Python 3.8 version. So first line, import pandas as a PD. Pandas is a library in a machine learning. It is used for to gather the data from the our JSON file. So read the data set from the CSV file name.salary.csv into the data frame. So DF is one of the variable contain the employee information, company, job, degree, and salary status. Salary more than 100K is a target and output column. Means 1 equal to the salary is more than 100K and 0 is equal to the salary is less than or equal to the 100K. So this is our the input and target variable. So in this line df.head, so it displays the first 5 row data set to understand its structure. Means Google company name, job description, more salary, etc. So in the next line, input equal to df dot drop salary more than 100K exists column. So here your data set df dot contains employee information, company, job status, and it predict the output based on the input feature, like input equals to all other column, company, job, degree, and target equal to the salary column. So our goal is to predict whether the person earn more than 100K based on their company, job, and degree and certifications. And the import scikit-learn pre-processing import label encoder. So encoder is one of the technique or method in machine learning that convert text into the numerical value or code. So that's why we import from scikit-learn library. Here we create a separate encoder for each categorical column. Means we apply a label encoder technique on each column. So many column contain the value like Google, sales executive or BTech certification names. So machine learning model need a number, not text. So label encoder convert this text label into the numerical codes. So that's why we include here label encoder. Labor encoder. So we here in this line input company n equal to the label company fit transform inputs company. So you drop the original text column and keep only the numerical version. So here we apply only the numerical version on this slide. The final input n data frame now contain only numbers. Read from the model training. So when we apply the label encoding here, when we convert input features, then it display the numerical value of that column. Input n means numerical feature column, encode company job and degree, and target equal to the salary more than 100K 0 or 1. So here we display the target. Target means salary is more than 100K 0 or 1. Here we display through the label encoding. And we import from scikit-learn import tree. Here we import decision tree from the classifier, create the decision tree model, model equal to the tree decision tree classifier. Here we create the inbuilt feature through the decision tree model. Import the decision tree from scikit-learn, create a new instance called as a model. Here we create an instance called as a model. A decision tree learn decision rule from the example like if a company is Google and degree is a BTech, then salaries are absolutely greater than the 100K. So that's why we apply here decision tree algorithm. So here we check model dot score input n equals to the target. You train the model using the input and targets value. So this input n and target value we also get from the previous label encoding as we can see in the PPT. The model now learn the pattern that link company job and degree to the salary level. So in this code here we get the input features and in the next slide model dot predict 2 comma 1 comma 0 the make a prediction for the specific employees. For example, if the employees work on the company like Google and his education is BTech, so we give the parameter 2 comma 1, then it return the either 1 or 0. If it return 1, then the employee salaries are absolutely greater than 100K. If it returns 0 means no, then employee salary is not greater than 100K.